only a chopper, it cannot cut to save its life. There have been documented cases of kukri blades chopping Japanese soldiers during the Second World War, where they split the helmet through and the blade gets wedged in the chin. Imagine that. That's a chopper. Can it cut? It sucks. Can the kukri stab like Fairbairn Sykes? Cannot. So what this book does is it analyzes all these different features, and you will find that in conclusion the Bowie has it all. It's got the weight, it's got the length, it's got the point, it's got the cutting edge. And what the Bowie knife has that no other knife has is the capability of what's called a back cut. Now, a back cut is a devastating thing, and it was the back cut that made this Bowie knife be banned because it was so nasty. Now, what happens, I'm going to use a rubber training knife. Thank you, Kevin. A proper fighting blade has a concave clip which, when used in reverse, not the primary edge, but it comes backwards like this. When used in reverse, it's got what they call a leading tip. Now, it was this leading tip philosophy that makes a knife like that work so well. That when you cut, the tip is first. A normal knife is this way around with cutting here. So if you hit, it collides with the cutting edge and rolls off the tip. And provided that knife is scary sharp, very often, I mean, we will know from the rope cutting, if you hit the rope on the curve of the tip, it glances off. Why, Niels, did you make your knife? Okay, he's going. Niels? Niels' rope cutting knife, or the wood chopping knife, it had a straight cutting edge. That, irrespective of where that knife connects with the rope, it cannot roll off the tip. Okay, so in a way, that knife, well, that was a straight edge, had what was called a leading tip. But the leading tip philosophy works like this. They give it a reverse cut. So they will often use the Bowie knife in double cut combinations. It's a slice hook, and it's always very, very fast. I purchased a set of 6 DVDs, Bowie knife fighting DVDs from a guy called James Keating. And he refers to himself as Master at Arms. Also, very, very experienced Bowie knife fighter. Now, just going back a bit in history, what they have done today, Bill Bagwell and James Keating, they have taken the old saber fencing techniques of the late 1700s, early 1800s, as taught to the military with their sabers, these curved swords. And they've taken all the saber movements and applied them to big knives. And there are 8, depending on which school you go to, sometimes I think it's 11 or 12 primary movements, and for every offensive there's an equal and opposite defensive. The guys who do is it kendo?
Yeah. Kendo and
yeah, you know, the Japanese sword thing, it's a similar thing, where for every cut there's the logical block. And they've put these into a logical sequence, because if I do this, he must do that, which then exposes him on the other side. So the logical next cut, it doesn't always work like that. I mean, you can chop chop from the same side, but you can give him a number 2 and a number 3. You see what I'm saying? So what they've, yeah, it's combination cuts, but what they have done is they've taken the saber fencing techniques and applied it to Bowie knives. And this is what these guys say. And it's a historical knife fighting method that is most likely to have been used by Jim Bowie when he kills these 4 oaks. You see, why would he have used a different method with his knife than he was trained with his saber? Just kind of makes sense to me. This particular knife is interesting, made by a guy called John White. A beautiful knife, and if you try and remember some of these names, I don't have that many of these famous names to remember. but I've chosen a couple of iconic modern day bladesmiths, Bowie makers, famous modern day Bowie makers, and then there's a couple of historical ones. But John White is one of these that whose work I really admire. This knife has what appears at first glance to be a full tang, but that's a narrow tang knife with what's called a frame around it. So this is a frame that surrounds the narrow tang like that, in the shape of the outline of the handle. And then your wood is still pinned through your narrow tang, but you are able to use handle slab. Okay? So you don't have to make a narrow tang knife bored into a solid block of wood. You can still make a narrow tang knife using handle slabs by using a frame tang construction. Okay, so that's just one thing there.
But do they use the coffin? That's the same on the coffin. What they do with the coffin handles as well.
They can, they don't have to.
Yeah.
I mean, a coffin can be a narrow tang into a solid block. It can be a mortise tang, which I'm going to get to one of these pictures just now, where you've hollowed out half the tang into two slabs, and by the time you put them together, it looks like one piece. And if you've got a piece of figured wood with grain structure, you want to split the wood, inlay your tang both sides, and put those two pieces back together. That looks like it was never cut. And I'm going to show you the way to do that, because you've got to align the wood grain this way. And by the time you split it and it goes back together, the wood grain from one side goes through to the other. And you can line that up to within 1/10 of a millimeter. I'm going to show you how. This is a particular picture pit. This was done with the edge in water. This was a knife that I made at a hammering, which we then proceeded straight onto the performance test with. So I demoed all the primary steps of forging, heat treating, differential tempering, and then the cutting performance test. So this just shows the differential tempering. That blue, that side is tough and spring. This part down here is still unaffected by the temper, leaving that edge hard. Okay? If you want to discuss more about this, if you don't understand or want more clarity, we can discuss it later. A lot of the bladesmiths here are able to help you if you're a beginner and want more clarity on this differential hardening, because it's the differential hardening that gives you the cutting performance but the toughness at the same time. This particular one is just a wire wrapping. Okay, so I wrapped copper wire, and then I flooded the copper wire over its hardwood core with super glue. So all the gaps between are filled, and then I just sanded it down, let the tops of the twist break through. It made a very interesting grip, and this little slideshow I've got here is really just, it's titled The Bowie Ideas. There was a time where I was in this like Bowie freak mode, you know,
which is like all the time.
Which is, you know, I keep joking with people, and when they say, "So what you making at the moment?" I say, "A Bowie knife for a change." Yeah, I think there were what 6, 7. So, I mean, those 7.
Just the one table.
Yeah, you didn't see the other table. But yeah, those 7 I kept as a. You know, it sometimes makes sense to work on a group of knives at a similar, and keep them at a similar stage, that when you're forging, and when you're heat treating. It sometimes gets a little bit monotonous, and sometimes takes a bit of the fun out of it. But it just increases your output. But if I'm not mistaken, that's this one. Southwestern Bowie. They will all be different knives, stag grips. Here's walnut burl. There's going to be a mortise tang, which turned out to be a coffin handle in giraffe bone. So they're all very different knives. They're all one-offs. There's no mass production involved there. And what's nice is you're forging these knives. They are freestyled here on the anvil. Every knife is different. You know, to make two knives identical is not so easy.
Neil says he's a bladesmith, not a manufacturer of machining tools and stuff like that.
You know, what's nice, these knives, none of them have templates. You know, every knife is unique. And the collectors of forged knives need to also just be made aware of that. And it does carry weight for them to know that theirs is a one of a kind. You know, these guys, you know, one doesn't want to, this is a saber meeting, so, you know, I don't feel I'm stepping out of line by promoting and standing up for bladesmiths a little bit. But where you've got stock removed knife makers working off templates, you know, they're giving a particular shape a name. And whether you want it with black ivory or wild olive, it's the same knife this year or next year. But you're on your way to being reformed. Jy kom nou reg.
You will.
Yeah, no, I mean, I love the forging because of this.
I can maybe just on that. I was last weekend. I was in Nelspruit at the Marula Makiti. We were three guys that was actually knife makers. Well, two knife makers and one blacksmith. So and the guys that came around, they said, but why is the other guys got 3-4 blades that looks similar? And neither of yours looks the same. Then I turned around and I said, you see that little pot that's standing there? I said, if you come around 12 o'clock, I'll show you why my blades all looks different. And I actually showed them from start on a coil spring and actually starts making a knife of it, and the guys were all.
Yeah, and very often forged knives are referred to as, gee, these are made the real way. You know, as if stock removal is not real, but no, never mind. But I don't mind opinions like that. It's good for us.
And then they say you're not rust.
Yeah, and then you say yes with a little bit of pride in your voice. All right, what makes this knife unique and part of the slideshow is that one was forged from a round bar. It is a Bowie. It has a clip point, stag grip. So all one has done there is hammered out the round bar, spread it nice and wide, and you leave this round bar as an integral ricasso, if you like. It's just a different technique. It doesn't have to have the typical cross guard, as we all think Bowie knives should have. Those two, both of them, were also integrals. That was round bar. I just made it into a hex.
I like the bone.
Yeah, just the raw bone. Those were both zebra bones. This one went through the dyeing and stabilizing process. This one was just left completely raw. But then the sheaths, gosh, I think the sheaths took me more time than the knives. So, but this is what I was referring to. When you choose a particular style, try and evoke an emotion. It's just, not just nog a mess. Please, you know, we see enough of those. Make it unique. Make it, let people think that their thing came out of a frontier blacksmith's workshop.
That looks like an Indian knife, almost.
Yeah.
The bottom one.
Yeah, whether you want to go sculpt people with it.
Just for kicks.
Right, that's a through narrow tang. Okay? Shows the segments going together here. These are oval washers, stacked one behind the other. This is a little bit of that S-guard guard that I was referring to earlier. You've drilled, and with a little raspy thing, and I've got a picture of that to show you, you have made the fit of your tang, the fit of your grip over your tang, such that it's not a narrow, skinny tang that fits into a round hole drilled into the wood. Because one needs to consider the longevity of your knife. Now, I'm talking knives in general now, not just Bowies, but it's something that I come across very regularly, where people rely on their glue or their epoxy too heavily. And if you go back in time, you'll find that some of the knives that have survived the best were manufactured with mechanical attachments and sometimes not even glue. Don't rely on your epoxy, because a tang into a round hole in 100 years time, 200 years time, I mean these Michael prices are from 1830s and the James Black, you know, from even before then. What happens if the glue in your wood fails? You land up with a wood turning on a tang. Okay, so you want to have a rectangular tang fitting in a rectangular slot into your wood. It's a through tang because you've got thread on the back onto which the butt cap or pommel, if you want to call it that, screws. I'll make a mention of this. That is mild steel thread bar, silver soldered or brazed, either way works, but not welding. Welding, you get a localized heat treat taking place on your high carbon steel, and when that thing is put under stress, the weld will crack next to the weld on the high carbon steel. So welding is a bad idea. But what I want you to notice, that thing has been scarfed. That's a blacksmith term, scarfed. It's ground off at a long sloping angle that the mating surfaces overlap like this. That the bonding surfaces are as big as they can be. You don't want to do a little butt weld like this. So now you've got a short little joint. Okay? So that is a long surface area there. Also, you're not going to make your extension back here. This must be integral to your knife as far and as long as possible. You want this tang to be as broad and thick as possible. Don't give your knife the opportunity to give narrow tangs the bad reputation that cheap commercial knives have received that have narrow tangs. The perception is narrow tangs are weak, full tangs are strong. No, you're making your narrow tangs wrong. Okay? This must be as wide at the shoulders as possible. The corner in there, you can't quite see it, must have a tiny little radius. There's a thing called stress rises or stress cracks that will propagate out of a sharp corner there. And if this is hardened through into here, which a forged knife should not be, okay? If you want to deep quench vertically, you stop your quench before those shoulders. You stop it there. Those shoulders should still be tough and unheat treated. Better still, you should be differentially hardening either with an edge quench or, as I've been playing with lately, the clay. Alright, so that just shows the proper construction of a strong tang with the extension done correctly.
Is there a rule overseas that you need to pin it now these days?
There's no rule.
No.
No, there's no rule. Customers like it to see a pin. It makes them feel better. But on that previous knife, with it screwed back, you've got a rectangular slot filled with epoxy. It can't go anywhere.
Yeah.
A pin would actually not be doing anything.
Aesthetic.
I mean, you could put a pin in. This particular one here, you'll see the picture of this knife with a mortise tang construction just now. But again, it's another group of blades. They're all Damascus. This one was the feather pattern. That one is just a random chaos, as was that one. Yeah, so this was a very big, heavy blade, that one. There we go. That's a mortise tang. Now, the idea of a proper narrow tang is that tang should go in as deep as possible. Now, sometimes the tang is longer than the drill that you have. So don't let that be the excuse. So now you're going to split that block of wood. Let's see if the next picture shows us better. I'm going to come...
Those are big ones.
Yeah, that's what I want to show you. Okay, so this is the block of wood that is split. But prior to splitting, you do this. You see that little protrusion with a hole drilled in it? So while it's still a solid block, a part of that block that is not going to be part of your knife, it's outside the outline. You just drill a hole and you pin it. Now, when that thing goes back together, the pin is just there to locate until it's all glued together. and afterwards you take that part away. Easy. But that's a mortise tank. So this hole is deeper than the drill might have been long. You with me?
Yeah.
So I'm going to use a carbide drill, for example, and only drill into my tang and pin it once everything has been epoxied together. One can put pins through the wood alone. Keep the wood together. You know, you'll often find pins around the periphery that will go through the wood only. But there will always be pins through the middle, through here somewhere, that will go through the tang. Okay, so let's just go back in my slideshow.
So Kevin, if you glue those together, don't you get a glue line there? What do you get? What do you do?
If you disc sand those two sides and you put them together straight away, there will be no glue line. When you do get glue lines, as in those surfaces are not flat, be careful you don't disc them so much that even after clamping, they are touching your tang. You want to put this on your milling machine, and if your tang measures 7 millimeters, you're going to drill this you're going to go down here 3.6, not 3.5. So you've got like 0.1 clearance. Then your tang must still be loose inside, just by a little bit.
You glue them with glue together?
You glue them with your epoxy. You know, the glue you are normally using, the epoxy. But if what I'm saying is you will just touch them on your disc sander and assemble straight away. Because wood, being wood, has the tendency to move and to buckle and bow. If you disc them today and you glue them tomorrow, you might find that they're not flat anymore. I see this talk is taking longer than I planned, so I'm going to chivvy up a little bit. Okay, so there's that mortise tang. That just shows the differential temper on a Damascus blade. The differential temper on a Damascus blade happens after hardening, and the hardening is a full hardening. It's not edge quench. An edge quench wouldn't be wrong, but for me to see a hamon, a hardening line, temper line, whatever you want to call it, running through the middle of a Damascus blade breaks the beauty of the Damascus. So you're going to fully harden your Damascus blade, grind it, polish it, etch it. After etching, you now do a differential temper, making the spine tough, the ricasso into the tang tough, and then you simply buff the blue oxide layer off, and you've got a differentially tempered blade. Remember, there's the difference between differential hardening and differential tempering. Okay? Again, if you want clarity and further discussion, we can talk later. Okay, but the reason for doing your differential temper after the etching is that your etch happens on a Damascus blade of uniform hardness. Okay, if you do your etch on a Damascus blade where you've already got a differential temper, you're going to land up with the depth of the etch and the way the etch looks varying between there, and it doesn't look nice. Just some more knives in progress. That's what's called your preform. That's just forged to the width and thickness of your ricasso, distal taper in thickness, and a simple profile. Now you start drawing out your cutting edge. That's the choil getting spread. I'm hammering a bit of a clip on here. So that happens after the preform. After this comes the forging of the tang and the refining of the shape. So those are actually going to be three separate knives, but what I've got there are the three distinct stages in your forging process. So a lot of guys just start forging and the edge is happening, but you don't even have a distal taper yet. Do things in a logical sequence. Establish your bar stock dimension, taper that bar out to the front, with your mass distribution. So if you're making a dagger or a kukri, your preforms are obviously going to have a different shape. I think that was those 7 knives that you saw on the bench earlier. That's all their respective lengths written on the blades, 11 inch, 11,4. These fighting knife guys believe that a fighting blade should be no shorter than 10 inches, 10.5 being a preferred minimum, up to about 12 inches. You know, they're talking about the knife you'll take on the devil with, basically. You know, I showed this one guy a very nice 10.5 inch fighting Bowie, and he says, yeah, that'll make a nice little concealment knife. Okay, so they believe they should be long, you know, like this. But again, maybe it was designed as a little concealment knife.
A woman's knife.
Work with a plan. You know, sometimes it's nice to freestyle, but it was described one time. Do you just jump in the car, you're going to a holiday destination you've never been to before, but you've never looked at a map. You know it's somewhere in the east. And you just like go on any road that's heading in the right direction. You know, you'll find dead ends and the road makes a loop and so on. Work with a plan. It may be a loose plan. You can change your mind a bit along the way, but have an idea of where you want to be. That this is going to be an 11-inch fighter Bowie with a mortise Tang construction, and another one's going to be a full Tang Bowie, and this one's going to be a wilderness chopper. You know what you want to make from the beginning. Yeah, dog bones and... There we go. If you don't like big knives, make little knives. But it can still be a Bowie. Okay, this is from a mini stag. It was only that high. What that was giraffe bone that I carved with a little Dremel tool. So I made it look like crown stag. That's made in the William Skagel style. Do any of you know him? He's one of our early modern day bladesmiths. Before Bull Moran. There we go. This guy surprised the pants off me. A customer of ours. One day he phones me and he says, that knife I just bought from you, it's got a staunch tang, eh? I say, it was a narrow tang, you couldn't see the tang. He said, no, I just x-rayed it. He's a dentist. You see, so in the end he took some of the other knives that he had and he x-rayed them as well. So don't believe that because your customer cannot see your tang, that you can bullshit with small tangs and skinny tangs and so, because in 100 years time that piece of wood you've used has frotted off and then they'll see your tang anyway. So watch out, you get dentists like this that are just waiting to catch you up. Don't let him find a little stumpy tang with a thread bar extension. Now that just shows how the washer assembly, you know, just behind the guard is located and prevent, you know, when you make it, they are made, the 3 layers together, that they are all perfectly flush and aligned with dowel pins, that when this is all assembled together, it goes together perfectly as you plan. Okay? There you can see the dowel pin and those 3 layers together. These are just aluminium profiles of the intended handle, because it so often happens where a guy makes a knife and he holds it in his hand and he realizes, damn it, it should have been a centimeter longer. It's too late now, you've made the knife. Or you look at it and you say, yo, the proportions are wrong. The handle that I plan or have made is out of balance proportionally to your knife. It's much cheaper to make a cardboard cutout or something like that and just Play with it like this. Hold it in your hand. See where the point catches you where it shouldn't be. Change it. Throw it away. Make another cardboard handle. And then decide what you're going to make and then stick with it. Don't waste your time on the real thing to find it's wrong. These are the little tools I use to bore out the narrow tangs of any knife. Okay, now these little tools here are just pieces of knife steel where the teeth that are filed in with a triangular file face backwards. So you're going to drill your holes out of your one blow. And then you need to rasp that little segment between the holes out to make a rectangular slot. So sometimes you drill 2 or 3 holes and they all go deep down into your block of wood. You need to open that up until it fits the tang that must go inside. So you've got these in different thicknesses, let's say thick Bowie knives, big hunters, small trout knives, say, different thicknesses. Then you've got these which are wood rasps, which I have annealed. You take a real rasp, you anneal it, making it dead soft. Then you bandsaw that thing, you grind it in width and thickness to where it will fit inside a narrow tang. Then you simply re-harden those things in your file. So you've just modified and customized some files and made your own little raspy things, and easy as that.
Is that a technical term, raspy thing?
Raspy things.
Yeah.
Yeah.
But only if it's got a handle.
You know, I see far too many full tang knives, but why so few narrow tangs? And I'll put it down to the people don't know about little tools like this, the clamping setups that you have to hold all this thing together while the slow curing epoxy dries. You know, it's all little tricks that you will learn. Stuart uses, do you still use quickset?
Yeah.
And do you still lean on it for 5 minutes?
Yeah.
Okay, I mean that method works.
It's a good time to contemplate.
I must give you some of my 12-hour cure epoxy and see what happens there.
Local knife maker found glued to bench.
Yeah, so there's a close-up of the ends. I've got them here if you want to have a look at the real thing. This is a Samuel Bell Bowie. It's more of a dirk than a Bowie per se. But this, remember these guys were silversmiths and artisans of different natures. They weren't just knife makers. These are stacks of silver, not nickel silver, put together and then silver soldered together with engraving. And then all of these little panels were filed and checkered, and tiny little silver wires drilled and filled with wire. Look at the detail there. Stunning, stunning, stunning.
That's a lot of work.
Heaps of work, as much in the silver sheath. So you can learn a lot by looking at these antique blades. This is an interesting guard. And it's this here that you need to look at. People will often say, now I'm going to draw. Coffin end. Okay. You want that guard to go on that knife. You draw the picture and it all looks very nice. But when it comes to making the guard fit on that knife, you realize, whoops, something is wrong. How do you get it on there? Because normally you've slid it over the back. Incidentally, you want to make it a full tang knife, because to put a narrow tang in here would be an easy solution. But let's say you wanted to make that knife a full tang, which this is. You can see that. You can't slide the guard over the back because the width of the handle is wider than the slot. You can't slide over from the front because your cutting edge is wider than the ricasso, so you're completely stumped. So you do it this way. Alright, you file that thing, you'll notice there's no choil, there's none of this. This would have slid up over the blade, particularly if this handle was flared. And then you do a soldered joint, you file it as close as you can, and then you seal it up properly with solder. Okay, so that, you can have a close look at that picture and analyze it and see why it was particularly interesting to me.
Can you pin it as well?
There's a pin over here, so that pin would be put in to prevent this thing sliding forward. The pin is obviously peen. You will peen this joint here, that it becomes a gapless fit right up at the tang. That if you file your fitting there is as close as it can be, just a little bit of solder in there will make it completely watertight, because the purpose of the solder is to prevent water going underneath here and giving your knife some rusting from the inside. Alright, let's quickly scroll through some more pictures and historical Bowies. Okay, we've seen that one. Samuel Bell. Okay. Here's another one of his. Look at the decoration on that. What distinguishes his work from other makers is this, it's called pique work. P-I-Q-U-E. All these little silver pins.